worse. You know what? It could be worse.
All right, so let's get rolling. Oh, first of all, if any of you follow me on LinkedIn, I am not changing jobs. I just took a chair position at a research company. I'm chairing their quantum computing research lab at OS Applied Research. And so I added that to the thing, and I guess it notifies everyone that I've switched positions. So no, I'm on the advisory board. I don't work there or anything. I'm just the chair of this like external board that makes sure that when they do their experiments, they don't blow up the world because quantum stuff can get pretty scary pretty quick, which is, I mean, I kind of hope that we open up a black hole or something, but I'm a little bit on the crazy side. It would be. Oh yeah, but you're young, you got all future in front of you. I've had a good run. Oh, I met your dad yesterday. Yeah. All right. So let's see, where do we leave off? What was your homework assignment? Okay, we're doing the dungeon crawl. What was it specifically? Make the guy go from one room to another. Okay, got it. All right. So let's look at that. Let's see where we're at. All right. So far in Maine, we are creating an instance of our dungeon with this stupid name. We got our player with this awesome name. So we are putting the player into the dungeon, telling the dungeon to display itself, telling the dungeon to start. So let's go into our dungeon class. Can I get this? Oh, wait, I think I can hide floating. There we go. All right, so as a reminder for you and me, our constructor for dungeon here is taking in the name of the dungeon. So we passed in that stupid name. You came up with it, right?
No.
He came up with it. All right, so, right? Yeah. Sleeper. Does he come up with it? Like he's got his hat down. He did it, right? Okay.
It wasn't.
Yeah. Well, I think she had an equally dumb name.
Combine that.
Yeah,
he came up with the first.
Yeah, it wasn't good. What you tried to do was not good. All right, so we the constructor for our dungeon takes in this name. We're naming our dungeon. So we're setting the field for this dungeon, this dot name equal the name. Then we're creating 2 rooms. So this is a very stupid dungeon. And at this point, all of our dungeons have exactly 2 rooms. We'll be modifying this as we go along by having a file that we read in to describe a dungeon so that we can create multiple dungeons that have different configurations and stuff like that. But right now we got 2 rooms. All right, we go ahead and let R1 know about his next room being R2. So just to go back into room and remind us. So a room right now has a name. It knows whether or not it has a player. So it has the ability to hold a player. It doesn't necessarily have a player in there. So when a room is first born, it has a name, but it sets the player variable equal to null, guaranteeing that there's not a player in there, even though that is the default value. It also has the potential to have a next room. So at this point, our rooms have exactly 1 exit. We're going to be expanding on that. All right, but it has the potential of having a next room, but initially it does not have a next room. So a room is just sitting here with a name with all this extra potential. It could hold a player and it can also connect to another room. All right, so back in dungeon. So we are saying room 1, we want to add a next room to room 2. All right, and then we go ahead and let this dungeon know the dungeon has a field called the entrance, which is a room. This is when you enter the dungeon, this is the room you start in, is the idea. All right, so we set the entrance to room 1. All right, so then we have this function called enter dungeon. If we go back to our driver, we see in main, we created our dungeon, so all that stuff we just talked about happens. Then we create our player. Player has a name. Let's go back into player here. So a player right now only has a name. I think we're going to find we have to add to that a little bit. Okay, but right now he only has a name. Then we go ahead and have the player, P1, enter that dungeon. So what does entering the dungeon mean? Entering the dungeon mean setting the entrance of this dungeon, which is a room. Up here, we've defined the entrance as a room. Setting that guy, asking that room to add a player, P, whatever was passed in to enter dungeon. All right. So we'll go into room. And down here, we have a function called add player. Add player takes a player in as a parameter. It overwrites the null value that was born into this room for the player. So remember, rooms are capable of holding a player, but they start off not holding anything. All they have is a name. So now we add this player to this room, which sets that null value, overwrites that null value with this particular player. And then we print out this player has walked into the room. All right. So that's what happens right here. Then we tell the dungeon to display itself. So we go into the dungeon, we go to display, and what does display do? It shows the entrance. It tells the entrance of the dungeon, which is a room. It tells him to display himself. So we go into room, and what does display for room do? Display for room prints out the name of the room, and then conditionally does some other things. It says, if there is a player in this room, if the player is not equal to null, we're going to print out that the player is also here and show the player's name. So we say also here, concatenate onto that this dot the player, because now the player for this room is something other than null, dot name. Secondarily, this is not an else. This is a second question. So we're asking two separate questions here. If there's a player in here, let's talk about him. If there's a next room, let's talk about him. So if next room is not equal to null, if we go into the constructor for dungeon, and we notice that R1 is the entrance, and we did add R2 as the next room to R1. So R1 does have a next room. So at this point, if we're looking at R1 here, he has a name, he has a player, and he has a next room. So if we tell that guy to display himself, we're going to get into both of these if statements. But if we were telling R2 to display himself, nobody's moved into R2 at this point. R2 does not have a next room. So if we asked R2 to display itself, it would just print out R2 because this if statement would fail and this if statement would fail. All right. So far, so good. All right. So back in main, remember all programs begin and end with main. After we tell the dungeon to display itself, we'll go ahead and tell the dungeon to start. All right, so let's see what that means. We go into dungeon. We go down to this function called start. We talked about the way we read stuff in from the user, or let's just say one of the ways we read stuff in from the user in Java. This is pretty much the standard way, is through this class called scanner, which lives in java.util, another library. So, when we first put it in there, we tried to compile it. It screamed at us and said, never heard of scanner. We went and looked up online, documentation for Java, show me Java scanner class. At the very top, it says it's in java.util. So what did we do? At the top here, we imported java.util.scanner. All right. Pretty similar to what we did in Python, I think, for our random number generator. I think we had to bring something in for that. Import random, I think. All right. So we go ahead and create an instance of our scanner. So this is the constructor. Has the same name as the class name. We didn't write this, we're just using it. Constructors always come after the new keyword. New keyword is our real estate agent. It goes and asks the operating system for some memory big enough to hold whatever I'm creating. All right, so the result of the new keyword will always be a memory address. So what ultimately would get stored in input is a memory address which points to where the scanner was actually built. All right, that's why constructors do not have a return value, because the return value is always a memory address, because they're always called using the new keyword, which gets a memory address. Make some sense? All right. And that's true in all programming languages, even languages that make you have a return type for the constructor. The return type will always be a pointer type. Always. All right, so we create our scanner. That's our ability to read stuff in from the user. Then we say, I want to do something forever. This would be an example where a infinite loop could be helpful because a loop runs until the Boolean expression is false. And the literal Boolean value true is never going to be false. We don't have the ability to update a literal that's built into the language. All right, so basically the only way we can get out of this loop is by breaking out of it. We have a special word called break. It exists in Python as well, exists in most programming languages, or an equivalent exists. In fact, you know what? I can't even come up with an equivalent in any language. Yeah. It's break, continue, or return. Those all three are in the same I don't know, category of drugs, if you if you will. Yeah, so and I've been exposed to a lot of programming languages, and as far as I can recall, it's always break. All right, break gets us out of the most local loop. Don't confuse that with it gets you out of the if statement. Break, this keyword right here, has nothing to do with this if statement. It will get us out of the most local loop we're in. So if this while loop was inside of another loop, that break would only get us out of the inner loop. We would still be in that outer loop. All right, so it gets us out of the most local loop. All right, so we're going to basically say, look, as far as I know, this thing's going to run forever, while true. We prompt the user, what do you want to do? We read in from the user what they want to do, input.next line. That reads in a string from the user. So anything the user types after they press enter, that gets that string. Now, I'll say something. You maybe even heard me say it when we were first kind of talking about the different kinds of programming languages, but Java is a string-based language. I'd like to reference it as that. If you have something in string format in Java, you can pretty much do anything you want with it. The antithesis to that, if you've ever worked with actually a newer language, Swift, strings are terrible in Swift. Very inconvenient to use. I mean, you can make it work, but it's not as convenient to use. Java is incredibly flexible. If you have something in a string format, you can convert it to an int as long as it actually is a number, right? You can convert it to a char. You can do anything you want with it as long as it makes sense what you're doing. It's very flexible. All right, so we're going to read in a string that's going to get captured into this variable called input line. Which is of type string. Now, historically, it would have been better programming practice to do something like this, string input line. And then right here, use the variable. So when you create a variable, you do not have to load a value into it. You're just bringing it into existence. In Python, you're always loading a value into it because it's a loosely typed language. So basically, the first time you create a variable, you are loading it, right? That's the point that the variable is created. In strongly typed languages, you can create a variable that holds nothing and then put something into it later. Just don't try to use it until you've put something into it. Now, the reason, why do you think this is in general better programming practice than we had before where we defined it inside the loop? Good.
It's good. Every time you go loop or make a new variable instead of use the same one, sorry.
So optically, every time this loop spins, which as far as we've defined it, it's forever. It creates a new version of input line. And so it overrides the previous version. Actually, historically, this would have given us an error a long time ago because it would have said, oh, there's already a variable called input line in the current scope. What are you doing? It does not create an error anymore, and it hasn't for a long time. Compilers are smart enough to recognize that in the current scope, you already have this variable and you happen to be in a scope of a loop. So it goes ahead and says, oh, I'm not going to recreate it. I'll just use the guy that was there before. I would say either of them is acceptable. just understand that it's kind of a behind the scenes trick. It's pretty common to do it this way. At some point, you don't want to just have a whole bunch of variables lying around in your code. Your code just becomes this big monster. So at some point, kind of organization becomes a little bit of a thing. And you're like, okay, look, we can be tedious about this, or we can just do what works. Kind of use your best judgment. But so any questions about that? It's not something I'll test you on. It's just a reality of life. This is something magical is happening behind the scenes for us that allows us to keep recreating this variable. All right. So each time through this loop, we will read in the next line from the user. So whatever they type, they press enter, that fires a string. It puts it into input line. Go ahead.
Can you just walk through how that creates an infinite variable? Like, what are the steps?
Well, it doesn't actually create an infinite variable. So historically, if we wanted to put a new value into input line every time through this loop, we would have defined the variable prior to the loop, brought it into existence. Don't have to put any values in it. It gets a default value. We could put a value in it if we want. But then we will just keep filling that same variable, overwriting that same variable. This would be the most logical way of writing it. All right. You don't want to redefine input line every single time the loop runs. Modern compilers recognize that if you're inside of a loop and you're defining a variable inside there, it's not going to keep redefining it. It knows that, okay, this is a loop. You just tried to get everything compact inside that loop. So we would say string input line in there. And because we are in a loop, let's say loop context, you're inside of a loop, the language knows, the compiler for the language knows, okay, we're not going to recreate this each time through. That's just, we're going to have this variable that belongs to the loop. It's a scoping thing. And it actually is more memory efficient because if we have it outside the loop, that variable then persists past the loop. It's still alive outside the loop. And for us, we don't need that. It's not hurting anybody if it's there. It's just not getting garbage collected as quickly because we are done using it, but it's still floating around there. But it'll die as soon as we hit the closing curly brace here. So it's not the end of the world. All right, that makes sense? All right. All right, so we'll read in whatever the user puts in. Then we're going to ask some questions about it. We're going to say, hey, string. We're going to call one of the string's methods. One of its methods is called equals ignore case. There's also an equals method that doesn't ignore case. So like Mike with a capital M would not match Mike with a lowercase m in that case. But using equals ignore case, they would. But they have to match identically otherwise. All right. You could write your own, even if equals ignore case didn't exist, we can convert the line to lowercase. We could say input line dot to lowercase dot equals exit in lowercase. And it would also work. That creates our own version of that. So it's not like equals ignore case is some magical thing. Internally, it probably just converts everything to lowercase and compares it, or converts everything to uppercase and compares it. All right, so if they typed in exit, we tell them goodbye, we break out, and the program's over. So go ahead and run this. We see it. Here's Mike has walked into the room. That's when we added him into room 1. We tell the room to display itself, room R1. Also here is Mike. Obvious exits are R2 because we did add a next room to R1. It says, what do you want to do? Right now, we only know how to exit. So it doesn't matter what I type here. It's going to keep going back through that loop over and over and over again. I kept pressing enter until we finally type in exit. When we type in exit, then we read an exit right here. We ask this question. We get a true from it. It tells us goodbye and it breaks out of the program. Make sense what it does now? All right. So now we want to have the ability to go to another room. All right, so what we can do is we can do something like this. Maybe we put in, I don't want suggestions from you, just do what I type. All right, so what we're going to do is we might have a whole bunch of if statements. You know, if you type in exit, if you type in look, if you type in whatever. So actually, let's do an else if just for look. So else if input line dot equals ignore case look. Maybe what that does is we wanted to show us the room we're currently in again. All right. So what room are we currently in? We have the entrance, but is it always going to be the entrance? It's not always going to be the entrance. It just happens to be the entrance right now. The room the player is in is whatever room the player knows they've been put into. Right now, we are not keeping track of that. A room knows about the player, but a player does not know about the room. So what we're going to do is we're going to add the ability for a player to become aware of the room they're in. So we're going to go ahead and say room, current room. We'll add that as a field to the player. We'll go ahead and go through the process of setting it equal to null when this thing first starts, because we don't like to rely on default values, even though this isn't necessary. So we'll say the current room is equal to null. All right, so now what we need to do is we need to have the ability to add a player, well, add a room to the player. Let the player know about the room they're in. Now, because we haven't made our variables private, we don't actually have to write a function for this, because we can access the player's current room variable directly. All right, we're going to keep going down that path right now because that most closely matches Python. We did talk about the public, private, protected stuff. If I were writing this, I would probably make current room a private variable. Therefore, I would have to write a function called like set current room, and I would pass in the room to the player so they are aware of it. In this case, we can access directly. So inside of room, when a player is being added to the room, we do have access to the player here, right? So we are letting this room is setting their player to the player. Go ahead.
Do you say that Java doesn't have built-in setters and getters?
It sort of does, but it's not like other languages. Typically, you'd write your own setters and getters in Java. C# has properties that let you pull it off. Most modern languages have properties that let you pull it off. I would say Java was a little bit before that. But because there is notation for like override, there's probably a metadata thing in Java that will generate setters and getters for you, but you'd have to kind of know this other language instead of it just being part of the thing. All right, so inside of add player for room, when we add the player to the room, we want the room to then let the player know about itself. So I want to say this dot the player dot current room. So the player has a field called current room, which is of type room. How does a room let a player know about themselves? This is the test to see if you understand an important concept. If I'm the room, I'm R1. The player has just been added to R1. And then I want to let the player know about me. So I say, the player, I want your current room to be me. How do you say that in Java? No, you almost had it.
This.
Just this. This is how an object refers to itself from within itself. This room, the current room, is just this. So player, the room you just entered is me. So inside of our classroom here, that's what we're in, room. This keyword is a pointer to this particular room. And we are sending that pointer into player and setting that player's current room field equal to the pointer to this room. Does that make sense? This keyword, as I've advertised, super, super, super important. And we need to be able to wield it. Okay, so that little sentence, the mantra, this is how an object refers to itself from within itself. Whenever you want to say me, you would say this. So if a room is trying to let the player know about itself, the way he refers to himself is the keyword this. All right. So now the room knows about the player and the player becomes aware of this room. Make sense? All right. So now a player knows the room it's in. All right. Let's go back to dungeon. We're adding an ability to our game to look. We want to be able to look around. All right. So we've gone down here and we've said, look, what we really want to do here is we want to have whatever room the player is currently in display itself. Here's the name of the room. There's a player in here, show the player stuff. If there's an obvious exit, show that kind of stuff. All right, so how do we get access? We're currently inside of dungeon. How do we get access to the room? Well, how do we get access to the player? Because we want to get access to the player's current room. So we need access to the player. So the question is, inside of our dungeon, do we have access to the player? First of all, up in fields, we have a name, we have an entrance. So we do not know about the player here, right? We have an enter dungeon where we have the player, but all we do is add them to the entrance, whatever the entrance room is. We don't actually have access to that player outside of here. How might I give myself? We know that a player eventually will enter the dungeon. That's the point. If we're dealing with players at all, they've entered the dungeon. How might I modify dungeon such that I have access to the player that has entered the dungeon outside of this function? Because I really want to make sure I have access to it inside of start. Okay, you could do that. So one possibility is we could say player, the player, and then out here in driver, when we call start, we could pass it our player. Oh, sorry. We could do that. But now we've kind of pushed the player through twice. It works. What he's saying works. All right, we'll even show it. So now I have access to the player inside of dungeon. Inside of start. I have access to the player inside of start. So now I can say the player dot current room, because that's the room the player is currently in, dot display. We know if we've started here, well, actually we don't know for sure, because technically the way we've written this, we could have called start before we ever put a player in the dungeon. That's possible. So really, we probably should ask, is the player actually in a room? We probably should wrap this with like an if. If the player dot current room is not equal to null, then we'll go ahead and ask that room to display itself. All right. In this case, we know we have put a player into the dungeon. So we know this player does have a current room. So we will get into this function. We go ahead and run this. Now we have two different commands we can give it. We can give it exit, which gets us out, or we can give it look. If we give it anything else, it just comes back to the prompt. So now we'll type in look, shows us the room we're currently in. All right. Because when a player gets added to the room lets the player know about itself. So now the player and the room both know about each other. All right. Now, what we've done in Dungeon so far, the way we gave ourselves access to player is by passing it into start, which is fine. Call it a B minus approach. Nothing wrong with it. It worked. We saw it. What's an alternative way that we might give ourselves access to the player? Whoop, I'm still running because I haven't exited out of my game. All right. So what's an alternative way that we can get the player into our dungeon class? Go ahead.
Make a player variable.
So player field, right? We're going to make a player field. So we'll say player the player. All right. So now the dungeon has the capability of holding a player. If we're going to do what we've done for other things, we would probably say this dot the player is equal to null. Make sure we've specifically said there's no player in here at the beginning. All right. So now a dungeon has the ability to hold a player. When the player enters the dungeon, we have access to the player. So what could we do here? You want me to get rid of the parameter? Okay, let's assume we get rid of the parameter. Do I even have access to the player at all now? I have a container for holding a player, but I just took away my one opportunity. The one time when the player gets entered into the dungeon, that's the time we have access to the player. He just walked in. So I need that parameter, right? Or one of my functions that gets called needs that parameter. We can put it into the constructor if we wanted, whatever. But if we were thinking about real life, could a dungeon exist without a player in it? Yeah, there's dungeons all over well, I don't know if they're all over the place, but let's assume they're all over the place in what, Midgard or whatever. And plenty of them are not going to have players in them. So if we're just following that logic, when we build the dungeon, it doesn't come with a player built into it. So it might not make tons of sense to have part of the constructor be a player that just is born with the dungeon. So a player really enters the dungeon at some later point in time after it's created. So that's this point right here. So when a player enters the dungeon, that is our first opportunity where we have access to that player. What we're doing right now is we are adding that player into the entrance to the dungeon, which is a room. We've seen that adding a player to a room also lets that player know about that room. So after this line of code, the entrance knows about the player knows about the entrance, knows about the room that's associated with the entrance, but the dungeon doesn't know about the player yet. How do we make the dungeon know about the player? Well, he just gave us a field that's capable of holding it. So I have a field up here that's capable of holding a player. I have a local variable here that is the player. What do I do? Set it equal to it. So this dot the player is equal to P, the player that was passed in. So now this dungeon instance at the top level, it's a field, a global variable inside the dungeon class knows about the player. So now I have access to the player anywhere inside this class, as long as the player has entered the dungeon. All right, so now when we are in our look thing here, it's no longer the player. It's now this dot the player. Before it was the player because we were passing in a local variable to start. So it was not the field. So we didn't say this dot. It was a local variable just called the player. Now we've moved that up to be a field inside the dungeon class. So the way we talk about fields is we say this dot the player. That is this instance of dungeon's version of the player. All right. Now, we still need to make sure that the player has a current room. We also probably should make sure, even though we know it's not possible, well, technically is possible. We probably should make sure that player is a thing. right? Nothing has required us to call enter dungeon prior to calling start. We could choose to just have a dungeon that is in existence that might have monsters in it, like rats scurrying around and stuff like that, and there aren't actually players around. That's a possibility in reality or whatever, right? All right, so we don't want to necessarily just presume that a player has already entered this dungeon. We know we called it first, so we know it's there. But what we can do is we can beef up our Boolean expression here, our Boolean expression right here. We can say if this dot the player is not equal to null, and this dot the player dot current room is not equal to null. Since we're doing an and, this is a Boolean expression, it's a more complex Boolean expression. For an and to be true, both sides have to be true. And programming languages are wise of this. So if this first part is false, it will not even try to check the second part. All right, which is good because we don't want it to check the second part if the first part is false, because if player is null, calling null dot current room is gonna be a problem. You can't call fields on nothingness. All right, so if the player is a thing and the player's current room is a thing, if both of those are things, then we'll go ahead and ask the player's current room to display itself. Make some sense? Good.
I've always found it that when I had that sort of thing, that if, let's say the player is null, it would still give me an error for the second photo.
You would have written it differently.
Is it a language specific thing or is it all like?
No, I can't think of a language that if the first part of an and is false, it will check the second. In an or, it will. In or, it'll check. It'll keep going because only one thing needs to be true for an or to be true.
I remember several times I've done that same thing. I've tried that. Right, I checked the first one and the second one.
Yeah. Try to create a scenario where it doesn't, and I'll look at it, but I can't think of a language that would work that way.
Okay.
For an and. All right. But it would be interesting if you can show me something that does that. I mean, I guess there's the first time for me to be wrong. Just ask my wife. Nope. Where you want me? Okay. And I'll put this code up when we're done. I don't necessarily expect you to, I mean, you feel free to code along with me, but as you see, I'm walking through it line by line. We're jumping back and forth. We're kind of letting this organically grow. So I kind of want you to follow almost like the programming process here. Then you go home and put in the reps of kind of doing it. Make some sense? All right. So, because what I want you to get out of class is kind of the mindset you go through when you're writing code. Just like we talked about first week of class where coding's like a sport. I can, I was a golfer before my back surgeries, but I can teach you how to hit a pitching wedge and I can maybe make it look easy, but until you've hit 10,000 of them, you're going to hit shanks, you're going to miss, you're going to, do all these things because you can academically understand what you're supposed to do, but until you've done the reps, you're not going to be able to do it yourself. All right. So I want you to follow the approach here and then go and try to work your way up to being able to mimic the approach. And then eventually you'll be able to do this stuff easily and you'll surpass me and all that stuff. And yeah, all that good jazz. Okay. So we're protecting ourselves here where we're only going to show the room for the player. If there's a player and the player has a current room, we know we would get in there, but we can run this. We'll see that this guy, oh my gosh, the dungeon.start. Oh, he broke the program. It was his fault. All right. Huh? Oh, you're right. Yeah. Right. Well, so he wanted to add that as a parameter to start. So inside of dungeon here, we used to have the player right here. Well, when I took it out there, this function no longer expects me to pass it anything. Yet I'm still in here in main passing it stuff. Not happy about that. But we look at the error message. Method start in class dungeon cannot be applied to a player. It requires no arguments. So read the error message. Requires no arguments, but I gave it one. So we'll just take that guy out of there because we've gotten our player into the dungeon a different way now. Go ahead and run this. Now we are back in business. We'll type in look and we see the players there. And the obvious exits are R2. All right. So now our goal is to allow that player to go into the next room. So let me exit out of here. So let's go ahead and do this where if they put in anything that isn't a built-in command. So right now we have two built-in commands. We have exit and we have look. If they enter in anything other than built-in commands, we're going to treat that as the name of the room. All right. And see if we can go there. All right. So from a player's perspective, they're going to see before that prompt that there's obvious exits to R2. So the idea here is that they would type in R2, maybe case insensitive R2 with a capital or lowercase r. Then we will try to put them into R2. All right. So what we'll do here in our prompt is we're just going to say else. Else means if you type anything else, we're going to see what we can do. We want to find out if the thing you typed in is the name of a room that is in here. That is one of the obvious exits. All right. So we're going to have a variable here called input line. And input line holds some string. We want to find out if that string matches the room, the next room of the room that the player is currently in. So if we go and look at rooms have the next room. Now the next room starts off at null. So we're not guaranteed that every single room has a next room. All right. So we do need to check that before we just start calling upon it. But so let's ask some questions here. So a player is in a current room. Go back to dungeon here. So we know we have access to the player. So we're going to say if this dot the player. And we'll continue to say if it's not equal to null. Not technically necessary because we know there's a player in here, but let's cover our bases. Technically, they could have called start without passing a player. So if a player is available and this dot the player dot current room dot next room.
Is it the next room?
Perhaps. You can check it here, go to room. Yeah, it's called the next room. Thank you. The next room. So if this dot, and I'm going to go ahead and just kick it down the line just so you can see it. Java, just like all other strongly typed modern languages, does not care if everything, you can write your whole program in one line or you can press enter in the middle of the line. It'll just keep going. Go ahead.
Checking the players commands. Check it once for the loop.
Well, you can't necessarily do that because there could be something that occurs externally to this that where a player could enter the world.
I asked you what you want to do, and the player's not in the world, and it's that.
I get what you're saying. Since we are talking directly to the player, well, it actually isn't talking to the player, it's talking to us, and we have we're a representation of the player. I mean, what you're saying is not wrong. There's somewhere in here where there's this gray area where if nobody's here, who are you talking to? It's kind of what you're saying. But in this case, we are running the program locally, so it's talking to us, and we might have a player that represents our will, but that doesn't necessarily mean we've put that player into the dungeon. Once we get into writing this as a multi-threaded thing, this dungeon's going to be alive, and there could be an opportunity where maybe we have a command that says enter. And that puts our representation into the dungeon at that point in time, where commands before that wouldn't work because the player isn't present yet. But what he's saying is accurate. I mean, there's an overkill point here where we are checking player not equal to null all over the place. Is it necessary? I mean, we could just make the decision that we won't let this. I mean, I think it's a good idea. Let's just do this before this loop even starts. We're going to say if this dot the player is not equal, oh, let's say if it's equal to null. We don't want to get into this while loop, right? So how do I make a program immediately end? Nope, break gets me out of a loop. Return. Right? So return makes this program, well, makes this function end. So return will make the start function immediately end, which takes us back to driver. And that was the last thing that we did here. So the next thing we'll hit is the end of main. All programs begin and end in main. All right. So by doing this, when we get into this while loop, we know a player exists. He might not have a current room. But realistically, if a player exists, he does have a current room. Right? So realistically, why don't we just ask a second question so that we can give the appropriate feedback? Because, I mean, his suggestion is good because it's going to make these if statements less complicated. So we'll say if this dot the player dot current room is equal to null, however that might occur. You know, you forgot to have the player enter the dungeon or whatever. Then we can say system dot out dot println the player is not in the dungeon. And we'll return again. All right, so we kind of have two roadblocks that we have to get past. We need to make sure the player exists, and we want to make sure he's in a room. If both of those things are true, then we can go into this while true thing, and we know that we're in the system. All right, so by doing that, we no longer have to ask, really, actually, either of these questions. We know he has a current room. We know the player exists. So we can take that entire if structure out. It's good we wrote it because we got to talk about the and Boolean expression there. All right, so we know that a player does have a current room, so we know we can ask it to display. We would not be in this while loop if the player doesn't exist and the player isn't in a room. Go ahead.
I'm just trying to understand how, like, when we pass P1 into the dungeon, enter dungeon, how does this stop the player P inside the void method receive that?
Okay, so we're gonna follow the yellow brick road. This is a good question. This is the type of thing I want you to see as I'm going through here. I always come back to main or wherever the starting point is. She wants to know, well, when we enter the dungeon, what happens? Well, let's read the story. This is where we enter the dungeon, right here, right? We're passing in P1. We're passing in the player. Here's P1. That's our player. So our player is entering the dungeon. The dungeon is a dungeon object. So we'll go into dungeon. Let's go find enter room or enter dungeon. So here's our enter dungeon, expecting a player. What am I doing with that player? Well, I'm going to the entrance of this dungeon, which gets built. When a dungeon is first born, we set the entrance, right? So if this dungeon exists, it has an entrance. We don't have to check it. We set that up here, right? This line right here, inside the constructor. So in order for this guy to exist, he has to have an entrance. Oh. Enter dungeon. All right, so we're going to take the entrance, which is a room. We're going to call his add player. And we're gonna pass it the player that just entered this dungeon.
Player, the player. Are we like trying to tell that this class that we have?
Well, yeah, but let's take one step at a time because we haven't gotten to that line yet. Right now we're on line 23. So don't look at 24 yet because we haven't finished tracing 23.
Yeah.
So 23 says this dot the entrance, which is a room. This is the entrance to the dungeon. Call that guy's add player, passing at the player. So now we need to jump over to the room class and look at add player. So we'll go over to room, scroll down. Here's add player. Let's see what add player says to do. Add player is expecting us to pass it a player. In this case, that player, the local variable name is called the player. So we have that. What do? Well, we set this room's the player equal to the player that was passed in. So at this point, the room knows about the player. The very next thing we do is we let the player's current room. So this dot the player is a player. He has a current room that he's in that starts off as nothing. We're going to set it to this. This is how an object refers to itself within itself. So as the player is added to this room, I'm also going to let the player know about me if I'm the room by passing a pointer to myself in, and I'm setting the player's field. How do you know that's a field and not a method or a constructor? Well, first of all, let's start off. How do you know it's not a constructor? No new keyword. Structures only exist after a new keyword. How do you know it's not a method? Well, it doesn't. Methods could exist that have no inputs. We have plenty of methods here that have no inputs.
No, but they're like, they're the curly bracket.
Yeah, we don't have that guy. No parentheses. All methods will have parentheses. They might not require you to put anything in them. They might not need any input to work, but they all have the parentheses, right? So that means as we're out in the wild, we're hunting, we're out in the wild and we see, oh, current room. What kind of animal is this? We can immediately disqualify constructor. We can immediately disqualify method. Well, all classes are made up of fields, constructors, and methods. So we only got one guy left. It's either a field or an error. One of the two. All right. So we make the assumption this guy might be a field inside of the player class because the player is an instance of the player class. We know that because of right here. Add player was expecting us to pass in a player. And we just happen to locally call it the player. So we look at player, we look at his current room. Here's player. We confirm that player right here inside the player class does have a field called current room. And what are we doing with that? We are setting I'm lost. Here's add player. We are setting that variable, that field, current room equal to this, the pointer to this room. That's where that line right there, line 37, is where the player becomes aware of the room he's in. Line 36 is when the room becomes aware of the player. Oh, well, the room remembers the player. We're putting it in a variable. So the room gets his local field, the player, set to the player that just entered the room, and then he lets the player know about himself. All right? And then we print some crap out to the screen, giving the user some visual that the players enter the room. That line 38 there is visual for the user. All right, so now we go back to dungeon. So this is where we put the player into the room. The very next line, line 24, is where the dungeon remembers the player. So that's the line you were just talking about. So this line 23 is when the room and the player learn about each other. Line 24 is when the dungeon remembers the player. So the way the player gets into the dungeon is by entering the dungeon. That makes sense, right? Real life, we would walk into the dungeon. And then the dungeon says, okay, I'm going to remember you. Okay. Facial recognition or something like that. All right, so the dungeon has a field up top of type player called the player. So the dungeon now knows at the global level the player that has entered it. Now this becomes more complicated later on when we have multiple players, but we'll get there. All right, we're doing the easy version first. Okay, but notice that we're bouncing back and forth between classes, but as we tell the story, it makes sense. But don't try to guess what it's saying. Follow the yellow brick road. If it says call this function, say, okay, what am I passing? And I'm passing it a player. Well, let's go make sure you wanted that. And you look at that function, say, okay, I passed in the right crap. What happens? And you look at the lines and say, wait, but then it says, oh, I got to go over here now. Well, what did I pass that guy? Unfold just resolve all the things until you see the patterns that are happening, and you're going to find that we're solving problems just like we do in real life. We're trying to make this true to real life, unless we get into a quirky situation where it's like, I got to do some weird computer stuff, something that wouldn't really happen in real life, but I can make it work here. Most of the time the language leverages the way we already solve problems, so we should be able to talk to it like we solve problems. All right? So, back down here, as I was rudely interrupted by a good suggestion. Java guy. Dumb dungeon name. All right, so inside of this else, we already know that a player exists. We already know that a player has a current room. All right. So we know that there's a room that might have the next room, right? We don't necessarily know that the player has a next room yet. He could be in a room with no exits. We hope that's not the case, but that could be like, it could be a jail cell, right? You're in a dungeon, you walk into the next room, the door closes behind you, thing starts filling up with water, spikes come down from the top, Indiana Jones style. I am having an Indiana Jones shirt made, by the way. I saw some of the graphics for it today. All right, so this one's Ghostbusters. Have I worn this here yet? Yeah. So there's Mr. Gonzalez. The elf on the shelf, dual wielding proton blasters. In the back, I think, is Backstreet Boys stuff. I think you get Backstreet Boys, Mr. Gonzalez there on my shoulder, maybe. I have a designer from one of my companies that I just pay her extra to. Actually, that's her. Her name's Megan.
Which company?
Huh?
Which company?
She currently is working with Cruise Optimization Lab, the thing I do for getting people free and discounted cruises. Well, through software. It's not like a side thing. It's a system I figured out because I go on a zillion cruises, so I might as well let it pay for my cruises. So I get free cruises by doing it, and then I sell the system to other people who pay me money to get free cruises themselves, and then I have money to get my drink package on the cruise. It's a system. Ay. Had I told you guys about the genetic test my wife made me do for the all right, we'll take a breather here for a second. I think I mentioned that my whole family is like Orthodox Jew.
Oh, you know.
Yeah, whole family's Orthodox Jew. I have cousins who are rabbis. I have female cousins who have arranged marriages in Israel. So, but apparently here in the United States, people who identify as Jewish, I am Christian, by the way. I didn't go in like a back door here. My brother and I are both Christians for a long time. But, apparently people in the United States who claim to be Jewish, they're usually like 40% Jewish or something like that because, the people have married and all that stuff. So my wife has me do a DNA test because she wants to start doing family tree stuff. So it comes back that I'm 100% Ashkenazi Jew. So she's thinking, okay, there's like no chance somebody is 100%. That's a 0.004% of the human population right now is 100% Jewish. So she has me do another test from a different company. Guess what that came back? 100% again. So I think it's solidified now that It is in my blood to look for deals. The stereotypes are real. My dad's one of 7 brothers. They're all doctors and lawyers. Every one of them. If you go to LipmanLaw.com, that's my Uncle Richie. Even has Rich in the name. Say this again. Oh, yeah. Who did you hear that from? Did I say it? I said it in here? Oh, yeah. That was when we went with Beautiful Savior. It's the church we were members of here in Mequon. It's an LCMS church. And we had a church trip to Israel. And just next to the Western Wall, the Wailing Wall, the last standing wall in the old city, there's this thing called the Holy of Holies where you have to be male and of Jewish heritage to get into. So it's kind of like it's become kind of a touristy thing, right? So you get this big long line of people who are, sitting there with their documents ready to try to get into this with military police checking stuff. I'm like 4th, 5th in line. This guy with, an assault rifle. It's like, waves me in. I think it was the nose. Look at that puppy. So, always fun stuff. All right. It travels with me to Meijer. When I go to Meijer, when I go in grocery shopping, I don't know what I'm going in to shop for. I'm going in to look for the red stickers that say 75% off. And keep in mind, I run multiple software companies. Money is not an issue. This is it's something that I have to do. It's like part of me. I can't pass up a deal. All right. What were we doing? All right. So now we're thinking about our exits. So we're back. Good.
Briefly, can you talk about this dot, the player dot, current room dot, the next room? How does you would switch some of those, would you get the same result?
Oh, no, definitely not. Yeah. So you read it left to right. So this dot the player, let's just start with that. This dot the player, when it's this dot, we're talking about a field inside of this guy. So we should be able to scroll up to the top and we see the player. All right, so that's the first thing. So this first part right here is going to be an instance of player. That's going to boil down to a pointer to where that player lives. Now, players, we go into player, they have a field called current room. And because I did not make this private, we have access to that field externally. So the next thing is I'm saying take this player and call his current room. So that whole thing right there will boil down to the pointer to the room the current player's in, or the player is in. Then rooms should have a field called next room. So we go to room. We see that a room has a field called the next room. So this is give me the player's current room's next room.
Does the next room reference current room? Like it's built off of, so it's like,
Yeah.
give me the next
So
room.
when I highlight this right here, all that stuff right there, that will, when that's resolved, it becomes just a room. So I'm holding a pointer to a room. It happens to be the player's current room. That's how I got to this. Okay, but I have a room right here, and now I'm asking that room to check his next room. All right. So this room has a next room, but when that next room is first born, he's equal to nothing. A room is not guaranteed to have a next room. So that's what we're checking here is for that. So we're asking a question here. I don't know when I deleted it, but so if this dot the player dot current room dot next room, it's kind of, you can think of it as kind of like giving the full path to a directory on your computer. Make some sense?
Sure.
All right. So if the next room of the room that the player is currently in is something other than null, that means there really is a next room. All right. So, and I'll put a little comment in here. We are going to try to leave this room and go somewhere else. All right. The somewhere else we want to go is going to be a room with the name input line. the value input line holds. So input line is my string here that gets set to whatever we typed in from the keyboard. So input line, if it didn't equal exit and it didn't equal look, then it's some word, right? Something that might be the name of a room that we might want to go to. That's what we're checking. Or it could just be gibberish. All right. So if there is a next room, then we want to ask the question, does that next room have a name that equals what was in input line? We really could write that all on one line with an and. Let's just put it as a separate if statement inside because I think it might be a little easier to read. Okay, so right now we've passed the first test. The room we're in has a next room. Now we're going to ask the question, is that next room's name equal to the thing I typed in? So if input line, that's the thing we typed in, dot equals ignore case. We'll let the user type in R2 in all lowercase or R2 in uppercase, whatever, okay? So if it equals ignore case, we want to say this dot the player dot current room dot the next room. Right? We know that exists. We're not in this if statement unless that's a thing. Dot name. So let's go into room. Let's confirm rooms have a field called name. Here it is. A room has a name. And every room must have a name. It's born with a name. All right. So we don't have to check if it exists. If the room exists, it has a name. So if that name is equal to, so if what we typed in is equal to ignoring case, the name of the room that the player is currently in. Well, the name of the room that the player is currently in's next room. If it's equal to the name of that guy, then we have a place we can go. All right. So now let's travel to that next room. So traveling to the next room requires two things. It requires removing ourselves from the current room and putting ourselves in the next room. Now, rooms already have the ability for us to add a player to them, right? So what we want to do is we want to tell a room, we want to add a new ability to room, maybe called leave room. And leave room is going to take, well, actually leave room doesn't even need to take anything right now because rooms only have a single player, right? And we know the players in this room, otherwise we wouldn't even be in these if statements. Let me finish writing this one part. So we are going to write inside of room. I'll put it up here. We're going to say void is not going to return anything. Let's call this leave room. Doesn't need any parameters. Because when we say leave room, it's going to be the player that's currently in that room is going to leave that room and go into the next room. At this point, there's only one player, and at this point, there's only one next room. Right? Go ahead. Is it related to this, what we're typing right here?
Yeah, I'm just general functions to like a class like that. What's like the best practice for like keeping it organized?
Yeah, some people alphabetize them. Some people will have like a section up top that's kind of for like utility things. And I would say it's kind of up to you, like how you like to organize stuff. I sort of just throw them wherever. And part of that is most of our modern IDEs will have a little drop down where you can just select your function. You don't have to scroll through and look at them. You can just say, give me this one, and it'll just get there. All right, so we're going to say leave room is a two-step process. We're going to first put the player into the next room. We don't want to say this dot the player equals null first, because now we've lost access to the player. Ultimately, when the player leaves this room, he will become null in this room. But before we do that, we want to say this dot the next room dot add player this dot the player. So the very first thing we'll do is we'll say, if I'm in this room, I'm going to take my next room and I'm going to add the player that's currently here, I'm going to add him there. Then I'm going to remove him from here. Now we already know add room works. That's how we got into this room, is through add room. So we know it's going to set that room's the player to the player, and we also know it's going to let the player know about the room he's now in. It's going to do both of those things. So we don't have to go do anything there. We just make sure we add him to the next room and we remove him from this room so he's not in two places. All right. So go ahead.
All right. Not variable, but like the constructor. Yeah, we did.
It's not in the constructor.
That, well, yeah.
Player has a field called current room. A player knows where he is, and that happened inside of the add, what we say, enter room? Add player, right here. It happens right in this add player, where we tell him about the room he's in when we pass in this. All right. So we're going to travel to that room, which means we're going to say this dot the player dot current room dot the next room dot leave room. And that should have us exit this room and go into the next room. Let's go ahead and run this guy. All right, so we see obvious exits are R2. We'll go ahead and type in R2 and we get a error. What was that? This dot next room is null. Where was that line that is complaining? Leave room. We lost track of our room somewhere. So it's talking about leave room. It's part of start, part of main. So it's leave room 16. Hold on. You're saying I called that wrong. This dot player, that current room. Oh. Thank you. Yeah, that was the error right there. I was already talking to the next room, which does not have a next room. So now I should be able to run this. It's the player's current room that I'm leaving. So now I should be able to type in R2. And now it says Mike has walked into the room. And now if I type in look, if I type in look, it now shows me that I'm in room R2. All right. So I'll give you a link to this code in Slack. No homework for Thursday. Maybe go back through, make sure you're following all this. Now I can type exit and I'm out of the game. So now we can move around our map. Maybe you can go and try letting R2 know about R1. So you can go back and forth between R2 and R1. Yep, sure.
I did mine a little bit differently.
That's okay.
Like a little different is not a bad idea. I just want to make sure that like going forward, if we continue to expand,